Hey guys, welcome back to the second part of the skeletal system. And this is Dr. Yu. Welcome back. So the first thing we're going to look at is the microscopic structures of a long bone. So micro means small. So this is very different than the gross structures that we talk about in the first part of the video. So microscopic, those small structures are very small, so you can't really see them with your naked eyes, right, without any instrument. So if you remember last time we talked about two types of osseous tissues, compact bone and spongy bone. And remember that compact bone is usually the external layer, very dense, smooth, and solid. And spongy bone is internal to that. And there is a lot of open space in spongy bone that's filled with bone marrow. So we are going to mainly look at the microscopic structures of a compact bone. All right. So the structure unit of compact bone is called osteon. Okay, so when you think about the bone synthesizing cells who are producing the bone matrix of compact bone, they're basically making osteons. All right. So what do osteons look like? When you look at this picture down here, you see some circular structures, right? This is one osteon, and this is another osteon, but they're not really circular because we're looking at the 2D image. They're really cylindrical. So I'm going to use this as an example. If I have to draw the entire osteon, it will be kind of like this, all right? And then it's going to go down all the way until the end of the bone. Okay, so this is, again, the structural unit of compact bone. Okay. All right, now the second structure is, which is part of the osteon, is called lamellae. So lamellae is pleura. So they are layers of a bone matrix within each osteon. So for example, if you look at this one over here, you see this is kind of one layer, right, of bone matrix. So that's lamella, so singular. And when you look at the multiple layers, that's lamellae. Okay, all right. Now you may also have lamellae in between the osteons, like in between, like over here. That's also lamellae. All right. Next structure, major structure, is called haversian or central canal. So that's going to be in the center of each osteon. So over here, there's a big cavity right there, and you can find blood vessels, lymphatic vessels, and nerves in the haversian or central canal. Okay. So those are the basic structures of osteons, which make up the compact bone. All right, now there are a few more structures. Osteocytes. Okay, so every time you see cytes, that's probably indicate it's some kind of cell. So osteocytes are bone cells, and you can find them actually pretty easily. So when you look at the compact bone within each osteon, right? If I draw the whole thing, this is, one osteon. So almost kind of in between two lamellae layers, you see darker line, right? So each spider-like structures, like this, and you can actually see a cell nucleus there. This is a one osteocyte. Okay, so there are more kind of like spider-like. And the osteocytes are actually live in chambers called lacunae. So this is one osteon, and then there's actually a little chamber, little space there that's called lacuna. So lacuna is a singular. So basically, they are the little houses that osteocytes live. All right. Now the last structure is called canaliculi. So canaliculi are actually very tongue-twisting canaliculi. So those are like a wrinkle-like lines that you see here. So all those lines are canaliculi. So those lines are actually little tunnels that can connect the multiple osteocytes, and this is kind of how they communicate with each other. All right. Okay. So let's move on. We're going to look at blood production in bone marrow. We actually mentioned this a little bit. So this is all about what kind of bone marrow you have. Right? So first know that only red bone marrow can produce blood, right? Can perform hematopoiesis. Yellow bone marrow is only lipid, right? It's just a storage site for lipid. So in children, all bones contain red marrow, even in the medullary cavity of long bones. That's all red marrow. But as the child grows up, eventually the red bone marrow in the medullary cavity of long bones is going to be replaced by yellow marrow. So that's what you see here. It's all yellow. All right. But long bones still have a red marrow. Where can you find red marrow? At the ends of long bones. So you can see over here, that's still red color, right? So that's still red marrow. And the red marrow is found in the spongy bone, right, at the ends of long bones. All right. Now, in adults, as most of the red marrow has been replaced by yellow marrow in long bones, they can still make blood, right, with the red marrow at the end. But now the sites for active hematopoiesis has kind of shifted. So you actually have other bones that are very active in producing blood, and those are the irregular bones like your vertebrae, your bones of pelvis, flat bones like ribs and sternum. Okay. So you can actually see in this adult picture, all those types of bones actually have a lot of red marrow, so they are very active in producing blood cells. All right, next we're going to look at bone cells. So bone is actually a very dynamic tissue. It's constantly made and broken down according to need, right? Where you have to, have more strength to resist pressure and stress. So how do you achieve this constant remodeling? So that's done by different bone cells. Okay. First of all, we have osteogenic cells. Genic, right? Like Genesis, you're making things. So osteogenic cells can develop into osteoblasts. So that brings us to the next type of a bone cell, osteoblast. So remember, this B kind of indicates build. So osteoblasts are the bone cells that synthesize a bone matrix. So they are known as the bone-forming cells. Okay. So who makes your bones? Osteoblasts. And where do osteoblasts come from? They come from osteogenic cells. So these are the stem cells that can develop into osteoblasts. All right. Okay, next one is osteocytes. If you remember that we actually looked at osteocytes not long ago, right, over here. They live in lacunae, right, in between the lamellae, the concentric ring structures. So the osteocytes are mature bone cells. They actually come from osteoblasts. So they come from osteoblasts. So as the osteoblasts synthesize the bone matrix, eventually they surround themselves with the bone matrix and they're not going anywhere. So they are kind of like trapped. But it doesn't mean that they're doing nothing after they're trapped. They continue to monitor and maintain bone matrix. And they can send signals to other bone cells like osteoblasts or osteoclasts to kind of tell them, what you need to do, where you need to remodel the bone. All right, the last one is osteoclasts. Okay, so you can remember that C for cleavage. So osteoclasts are involved in bone resorption. So basically, they break down bone matrix so that you can rebuild, right, based on need. So those are the main types of bone cells. So again, remember osteoblasts, B for building, right, building bone matrix. And then on the other hand, you have osteoclasts, right, cleavage, so breaks down bone matrix. All right, next is the chemical composition of bone. So we are going to look at, comparison between organic and inorganic components. Now they are very different. They serve different purposes in terms of bone tissue. So the organic components include the cells, right, and some other organic part of the matrix. But the main thing that you need to remember is the collagen fibers in the bone matrix. Okay, so the collagen fibers are protein fibers. They can be, pretty big relative to other protein fibers. So they provide a really good resistance or resilience. So it makes the bone more flexible and resilient. Okay, so that's protein or collagen fibers in terms of organic components. You also have inorganic components, and this is actually the majority of bone matrix, over 60%. And that's mostly mineral salts, and specifically hydroxyapatites over here. And that's basically salts of calcium and phosphates. So these inorganic mineral salts are very hard, so they provide hardness. So that's what makes your bone really strong, like really hard, compared to soft tissues or even cartilage tissues. So we kind of talk about this a little bit. So this is kind of related to the bone mass or density. Okay. So if the inorganic components, right, the calcium sulfates, those salts, especially the calcium, is taken away from your bones, from the bone tissue, then it's going to make bone mass less dense. So you are going to experience a loss of bone mass. And how can that happen? Remember we said that the bones are really serve as a bank for calcium, right? A bank for calcium, because it's a storage site for calcium. So your body has other functions that require calcium. So your body may withdraw calcium from your bones to perform other functions. Or your body could, deposit and store calcium in bones. So it's a kind of constant process. Now, if you withdraw more calcium than has been deposited, then your bone density will decline. Okay, and this will definitely happen to people who have a deficiency in calcium or even vitamin D, because vitamin D promotes the absorption of calcium. People who have those deficiencies are going to, suffer a loss of bone density. All right, so we're going to talk about a few diseases that are related to that. Now, let's practice with some questions. Question 1. So hematopoiesis, remember this is blood production, right? So where is blood produced? Right, bone marrow, red marrow. This is easy because red is the same color as blood. Number 2. So which of the following cells is involved with mineral resorption? So resorption, you are breaking down bones, right? You're kind of resorb all the minerals away from bone tissue. So this is going to be osteoclast, right? See cleavage, remember? And that's basically the same as breakdown. Number 3. So basically this asks you what is the structural unit of compact bone, right? Because this is centered around. So when you build compact bones, you are building bone matrix around, this particular structure. So that's not going to be any of these bone cells. So the correct answer is the structural unit, which is osteon. Number 4. So the question asks for flexibility. There are 2 main characteristics for bone. The first one is flexibility, and that's provided by the organic components, especially collagen fibers, right? And the second characteristic is hardness. So hardness is provided by inorganic calcium salts, right? Calcium and phosphate salts. So mineral salts. So flexibility, that's going to be collagen. Right? So these are all mineral salts, calcium, magnesium. Elastin is also a type of protein fiber, just like a collagen. So it's smaller than collagen, It's usually found in organs that needs to be kind of stretched and needs to recoil back. So usually found in things that are going to be stretched a lot, and it needs to recoil back. So where can you find elastin? Usually in these places, like blood vessels or the walls of blood vessels. Because every time the blood that goes through, especially when you look at the arteries, the blood is going to stretch your blood vessels. And then after that wave passes, then your blood vessel wall will recoil back. You can also find it in skin. That's what makes your skin really kind of not bouncy, but if you press it, it can come back. Right? Question 5. So this is kind of a long question. Which of the following processes explains why an individual that has suffered a broken bone and is immobilized for an extended period of time experiences bone mass loss? So remember, we talked about that the bone is actually a tissue that's very dynamic, right? So it goes through resorption and building, all the time. So which one will cause bone mass loss? Now, if you don't move for a long time, if you're immobilized, then it doesn't add, stress or pressure to your bones to make your bone weaker. So actually exercise actually kind of helps your bone become stronger. So if you're immobilized for a little while, you don't have that the signals or the stress that can make your bone become stronger. So you will probably experience a bone mass loss. So which is the correct answer? If you experience bone mass loss, that's mostly the inorganic mineral salts, right? The loss of inorganic mineral salts. So when you go through the answers, demineralization. So D means you're losing those minerals. So correct answer is D. Kyphosis is actually abnormal curvature of your spine. So I have a picture right here. So kyphosis is specifically when your spine has this abnormal kind of outward curvature. Okay, so that's kyphosis. That's what kind of gives you like a hunchback. Muscle atrophy, so this is about bones, right? It has nothing to do with the muscles. Ossification is almost the opposite of demineralization. So your body is making osseous tissue. So it's not the correct answer. All right, the next topic is about joints. So we're going to go through the different types of joints real quick. Now, based on structure, we can classify joints into these 3 categories. The first one is a fibrous joint. So in fibrous joints, the bones are held together by dense connective tissue. Okay. So you see it's called a dense connective tissue, right? So a really tough type of connective tissue. So this is what can really kind of hold your bones together so they don't get separated, very easily. Second type, cartilaginous joints. In this type of joint, it's the cartilage that kind of connects the bones. All right. And the last one, this is the most kind of complex type of joint because you have multiple structures to form the joint. So this is called a synovial joint, and this is pretty much the most common joint, what everybody is really familiar with. So in synovial joint, you are going to have a joint cavity. Okay. Over here is really just a kind of introduction of terms. Arthrosis, junction of 2 or more bones of the skeleton. So basically, arthrosis just means joint. So a lot of times you will hear the word articulate. Okay, so articulate really just means that 2 or more bones join together to form a joint. All right, let's look at some examples of a fibrous joint. A very good example is actually sutures. So you find sutures in the skull, right? So sutures are made of fibrous, dense connective tissue, which hold your skull bones together. Now remember I said this tissue is very tough. You need that, right? Because you don't want your skull bones to kind of, separate from one another and there's a gap. You can also find the fibrous joint in between ulna and the radius. So these are the two bones in your forearms. So those bones are also kind of connected or held together by dense connective tissue, fibrous joint. The last example is actually the gum, right? So this particular type of fibrous joint is called a gymphosis based on the location. So your teeth are actually held in the sockets by dense connective tissue. So this is actually a type of a joint. And again, remember this fibrous joint is very tough, right? And this is what keeps your teeth in the sockets, so you don't just randomly have teeth falling off. That will be really bad. All right, so for fibrous joint, it's immovable, because you don't want any of these things to move around, right? You don't want them to be loose, so immovable. Second is cartilaginous joint. So remember, the bones are held together by cartilage, right? So this is actually fibrocartilage, a type of very tough cartilage. So you can find a cartilaginous joint in your spine or your vertebral column. So in between the vertebrae, in between the bones, you see there's a disc, right? So that's a disc of fibrocartilage. It's very resistant to compression. So it's a very, very good structure to have in your vertebral column. The next one is pubic symphysis. So this is your pubis bone. Okay, over here, this is your pubis bone. So in between these two bones, again, there's a disc of a fibrocartilage. Okay. So for cartilaginous joints, they can move slightly. Okay, they can move, but it's very slightly. So think about your spine. You can, do some movement, right? So it allows you to move a little bit. And also for pubic symphysis, especially when a woman gives birth, this can be kind of moved a little bit, right? Can open up a little bit. So the last type of joint is synovial joint. So there are a few characteristics. So first of all, the adjoining bones are covered in articular cartilage. Remember, articulation refer to joint. Okay, so the cartilage that covers the ends of bones that form synovial joint is called articular cartilage. So when you look at these, there are two bones, right? Form this particular joint. And then when you look at the ends, this kind of blue color, that's a layer of cartilage. Okay, that's the articular cartilage. The bones are separated by joint cavity, right? They don't touch or anything. There's no kind of like solid structure to directly connect them. So there's a space in between the adjoining bones. The joint is enclosed in an articular capsule. So the articular capsule is over here. So it's a layer right there. So that's the capsule. Now you're gonna ask, so what is the layer that's internal to the articular capsule? This kind of orange color layer. That's called the synovial membrane. So the synovial membrane can secrete synovial fluid. Synovial fluid. And this fluid is very important because it lubricates the joint, minimize friction. All right, now all synovial joints are very different than the other two types of joints. They are diarthrosis, don't worry about the term, but basically means they're freely movable, right? You can move your wrist, you can move your elbows, you can move your knees. They're freely movable, a wide range of motion. So here's some additional information. I don't think TEAS will ask you this, but just in case. So you have a hyoid bone. It's actually in your neck. So hyoid bone is the only bone in the body that does not articulate with any other bones. So it's hanging there. There are tendons, muscles attached to it. So again, that's the only bone that does not form a joint. We need to look at ligaments and tendons to know the differences between those two, because I have seen questions on the differences between those two structures. So the difference is actually very straightforward. Remember, we just talked about joints, right? So you have adjoining bones. So ligaments, well, the ligaments connect bones to bones. Okay, so when you look at this joint, now external to the articular capsule here, you will have some really tough connective tissue. So that layer of connective tissue is a ligament. Okay, so again, ligament kind of connects bones. And the tendons attach muscles to bones. So when you look at this picture, is that this is a piece of muscle, skeletal muscle right here, and you see that white color part at the end of the muscle. Over here, this part is tendon. So the tendon attaches a muscle to a bone, right? Usually it's some kind of bone marking, some kind of something that sticks out for the muscle to attach to. All right, so that's the difference. Ligaments attach bone to bone, but tendons attach muscle to bone. I include this picture because it has both structures. So you have muscles, right, and there's the tendon. See, the tendon kind of keeps the muscle attached to the bone, and then over here you have the ligament. So the ligament holds the two bones together. All right, the last part is about common diseases of bones and joints. So again, a lot of times these diseases are related to the chemical compositions of bone. So I have the information here just kind of as a reminder. So the first disease is brittle bone disease. So brittle means the bone is kind of hard, but it's a little bit too crispy, almost like crispy. Very fragile, very easy to break. So this is also called osteogenesis imperfecta. So the disease is caused by a lack of collagen in the bone matrix. So without the collagen, you don't have that flexibility, right? You don't have that resilience. So the bone is very brittle, very easy to break. The second disease is called osteoporosis. Now, you probably have heard this quite often. I know on TV there are a lot of ads for drugs that target this disease. So basically it's a loss in bone mineral density. So you can think of it as kind of bone thinning disease. This is often caused by lack of calcium and vitamin D in the body. We mentioned this, right? Without the calcium, without the mineral salts, your bone just lacks that hardness. Sometimes it's also caused by just natural aging, right? Especially for women, because you also have a decline in estrogen, which is kind of important for the for healthy bones. So with declining estrogen and with aging, a lot of older women tend to have osteoporosis. Next disease is osteoarthritis. So this is about your joints. Okay, so this is a degenerative joint disease, and the degeneration takes place in your articular cartilage, right? Remember we talked about the articular cartilage right here. So this is a normal cartilage you can look at here, and then this is what the cartilage looks like in the patient that has this disease. So you can see the cartilage is really worn out, right? So there's a lot of erosion in the cartilage. And when you look at this with the x-ray, you can see with a healthy articular cartilage, you have a good space, right, in between the bones. But as the cartilage is eroded, this space is getting smaller. So you may have two bones that are too close to each other, and that's gonna cause a lot of pain. The last one is rheumatoid arthritis. So this is also a type of arthritis, but this is caused by your own body's immune system attacking its own tissue. So it's autoimmune disease. So the immune system is going to attack tissues, including the joints. Now, it doesn't happen just to the cartilage like the previous disease, osteoarthritis. It also attacks all kinds of tissues in the joint. So you may have bone erosion, which eventually lead to joint deformity. So there's a picture right here. Okay. So again, remember this is autoimmune disease that causes joint inflammation and also a lot of pain. All right, now let's practice with some questions. Number 1. Okay, so skull bones, remember the sutures? It's which one? The fibrous, right? Fibrous joint. Radius ulna, that's also fibrous. Remember, that's the second picture on that slide. Bones of the pubis. Ooh, which one's that? That's the cartilaginous joint, right? So you have 2 pubis bones, and then in the middle you have a disc of fiber cartilage. So the correct answer is the last one, right? Humerus and the scapula. So that's your shoulder joint. And the shoulder is a type of synovial joint. Number 2. So to answer this question, first you need to know what's osteoporosis. Remember, that's a bone thinning, so you have a loss of mineral salts. So that's the first thing you need to figure out. And then the second one is which cell causes a bone resorption, or which cell breaks down the bone matrix. Osteoclasts, right? C for cleavage. So it breaks down bone matrix. Next question. Tendons connect muscle to bone, right? So this should be B. And ligaments connect bone to bone, right? On this slide, I just want to point out some of the typos in the official study manual. And I don't know if it's just kind of inaccuracy in the language or some other reasons, but I don't like some of the wording. So for example, on page 128, the skull consists of mainly actually flat bones and not irregular bones. So most of the bones in the skull are actually flat bones. Remember, we talked about the frontal bone, and then you have parietal bones, occipital bones, and those are all flat bones. Next one, knee and elbow. To be accurate, they're really joints, right? They're not bones. They consist of bones, but they're actually joints. So if they mean specific bones, like in the knee joint, patella is a special type of bone. Remember, that's a sesamoid bone, right? And then other bones that form the knee joint, like femur, tibia, fibula, so those are going to be long bones. All right, same thing for the elbow. So all bones forming the elbow are long bones. So that's humerus, radius, ulna, those are all long bones. All right, good job. You finished lesson 4, the skeletal system. So keep up the good work, and I'll see you next time.